Okay, this is the main question. Okay, they are asking in the examination. There are explain the memory mapped IO mapped IO related to what the IO devices. Okay, there are two schemes are available to connect it to the IO devices one another with through what the CPU processor. One is for the memory mapped IO, another one is for the IO mapped IO. Memory mapped IO. This is what the memory mapped IO. Here only what the only single bus is used. Only single bus is used. What is that? Why the single bus is used? Here the both the memory and the IO devices are communicated toward the CPU processor with the only what the one type only one type of bus we call as the single bus. We call it the single bus we are using. If you want to communicate with the memory and the IO devices to the processor, we'll be using only what the only one bus and single bus. That when the if you want to communicate, if you where the only one set of instructions are used for the both the memory and the IO devices. We don't have the a separate set of instructions. Okay, separate set of instructions. The only one the set of instruction that is used for the memory. Those instructions are used for the IO devices also in order to communicate to the CPU. That's because the only. And also we are the here we will be using the separate the example for the this memory mapped IO is the move data in registers to the R0. Data in is the one of the virtual registers. This is the source registers. This is the what the destination registers. If you want to communicate, okay, if you want to communicate with the processor to the to the registers, okay, if this is what the memory, this is what the memory, this is what the IO devices, this is what the IO devices. If you want to communicate the IO device to the CPU, we'll use the what type of instructions? Memory related instructions. Memory related instructions. This is what the move instruction that is used to copy the contents of the data and registers to what the registers R0. R0 is what the one of the registers which is present in the processor. This is what the processor registers. This is what the registers source register. That is because the input devices. This is what the input device. Okay, and also. Okay, if you want to communicate with the only the memory devices, that's the only type of only one type of instruction that we use for the memory related instructions. You should remember these points are very important. And also we have the in this technique both the memory and the IO devices use the common bus to transfer the data between the processor and the memory and the devices. Only common bus we are using. Okay, this is all about the memory mapped IO. Memory mapped IO. Come to the next point that is called the IO mapped IO. IO mapped IO. How the input devices and output devices connected to the throughout the processor. Okay, with the we have the separate buses here. What the one bus is for the memory related, another bus is for the IO devices. We have the two types or two set of instructions. One is related to memory instructions and also related to IO device. Separate set of instructions are we are using. And also we communication purpose we have the separate buses. Okay, two buses are there. Two buses are there. Okay, one set of instructions for the memory operations, another set of instructions for the IO devices, IO operations. Means what there are two set of instructions are using. Okay, best example for this one is what the in is the one of the instructions which will be copying that one is from the AL. AL is the one of the registers. Okay, AL is one of the registers. This will be copied to what the DX registers. Okay, this is what the input device. This is what the input related instruction. This is what the in instructions is what the input devices instructions. This is what we will be using what the in the memory mapped IO. The memory related instructions are used to communicate with, to the processor even the for the both IO devices and memory. But here the separate instructions that are available in the IO mapped IO because of the communication. We have the separate buses are there for the memory communication purpose and even the IO device communication toward the processor itself. Okay, for example, here the one of the instruction that we call the input related instruction, that is the in AL DX. It's we are what we are copying the from the input device. We are copying the contents to what to the another registers that we call the DX. These are the 16-bit registers we are using here. Okay, this is all about the memory mapped IO and IO mapped IO. This much is enough. Okay, just to copy. ಅಷ್ಟೇ ಇದಮ್ಮ ಅಷ್ಟೇ ಇದೆ
ಸರ್ ಇದನ್ನ ಹೆಂಗ್ರಿ 10 ಮಾರ್ಕ್ಸ್ 7 ಮಾರ್ಕ್ಸ್ ಸಿಗೋದು ಗ್ಯಾರಂಟಿ ಎಷ್ಟು ಎಕ್ಸ್ಟೆಂಡ್ ಮಾಡ್ತೀವಿ ಹೇಳ್ರಲ್ಲ ಆನ್ಸರ್
Just much, okay, just to write, okay. There are two schemes are available in order to communicate with the IO devices and the toward the processor. One is called the memory mapped IO, another one is the IO mapped IO. Okay, just to copy, okay, first memory mapped IO, very diagram ಹಾಕ್ಬೇಕು. Okay, in this we have the, in order to communicate with the memory and the IO devices to the processor, we'll use only what the single bus. Okay, for this purpose we have the only one type of instruction that we use for the memory related instructions. This set of instructions are used for both operations. One is for the memory related operations and also even IO related operations. Okay, in order to communicate with the data transfer between the memory and the IO devices, we'll use only what the single bus, we call the one bus. That's what we'll use the what the, ಹೌದು ಅದನ್ನು ಎರಡು ಸಲ ಬರೆಯೋದು, ಎರಡು ಸಲ ಬರಿಬೇಕು. ಹಂಗೆ ಇರ್ತದೆ ಅವಿ in this techniques. Okay, in this separate we have the address space for this memory, and if you want to communicate with the memory through what the CPU, will use what the separate memory related space. This space is this same instructions are used to communicate with the processor, and even the same instructions are used to communicate with what the IO devices also. ರಿಲೇಟೆಡ್ ಸೇಮ್ ಇದೆ, ಸೇಮ್ ಇಲ್ಲಿ ನೋಡು, ನೀನು ಓದು ಆಯ್ತಾ, ಇಲ್ಲೇ ಐತೆ ಫಿಗರ್. ನಾನು ಹೆಚ್ಚಿಂದ ಹೇಳಕ್ ಹೋದ್ರೂ ಬೇರೆದು ಹೇಳ್ಬೋದು, ಹೆಚ್ಚಿಗೆ ಸಿಲೆಬಸ್ಗೆ ಏನಿರುತ್ತೆ ಅದೇ ಹೇಳಕ್ಕಾಗುತ್ತೆ, ಹೆಚ್ಚಿಗೆ ಹೇಳ್ಬಾರ್ದಾಗುತ್ತೆ. ನೆಕ್ಸ್ಟ್ ಇಸ್ ವಾಟ್ ದ only the one type of instruction, that is we call as the memory related instructions are used to communicate with to the processor, even both the instruction IO devices and the memory also. If you want to communicate with the processor, we'll use the only one set of instructions that we call as what the memory related instructions. Memory related instructions. And also we have the one example here, the move data in or not. Here the data in is the source registers, destination registers. For example, if you consider if you want to communicate with the keyboard, whatever the input devices, will copy the contents of the data registers to what the register or not itself. This is all about the memory mapped IO. This is all about the memory mapped IO. Come to the IO mapped IO. In the IO mapped IO, we have the separate two buses in order to communicate with the memory with the processor, and also IO devices with the processor. For this purpose, we have the two set of instructions. One is related to what the memory related instruction set, another is what the IO related instructions in order to communicate with the processor. Okay. For example, if you consider with the AL in AL DX, here the in is one of the instructions which is present available in the input devices. This will copy the contents of the AL registers toward the DX only. It is moving the contents of the AL registers to the ಅದೇ ನೆಕ್ಸ್ಟ್ ಇದೆ, ಅದೇ ತಗೋತೀನಿ. ವಾಟ್ ಆರ್ ರಿಟರ್ನ್ ಆನ್ ದಿಸ್ ಒನ್. ಓಕೆ, ಐ ಆಮ್ ಎಕ್ಸ್ಪ್ಲೇನ್. ಅದರ್ ದೆನ್ ದಿಸ್ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡಿದ್ರೆ ಸರ್ ಬೇರೆ ಹೇಳ್ಯಾರ ಅನ್ಕೋ ಹೆವಿ ಆಗಬಾರ್ದು. ಏನದ ಪ್ರೋಗ್ರಾಮಿಂಗ್ ಅದೇ ಅಷ್ಟೇ. Here the address space for the memory and the devices will be used only one because of the single bus structure. Address space for the separate, you are the memory and the IO devices, because of the we are having the two separate buses here. The address space for this memory is alag, this IO device is alag, but the same, because of the same bus we will be using both the memory and the IO devices, so that the address space is only what the single one. Here the single, but we have the separate address spaces for this one memory and the IO devices in order to communicate to the what the processor here. This is all about the memory mapped IO and IO mapped IO. Okay, take the heading as the difference between the memory mapped IO and the IO mapped IO. What we are doing here, the data is transferred from the keyboard to memory to the CPU, process CPU to the memory. But here we will be copying the contents of the memory, even the separate buses you are using, and even the communication between the processor and the memory and the processor and the IO devices will be alag. Take the difference between the memory mapped IO, IO mapped IO. On the left side, memory mapped IO. Memory and the IS share the entire address range. Okay, first one take the heading. Okay, memory and the IO share the entire address range of processor. Memory and IO share the entire address range of processors. Second one is this. On the right side, take the processor provides the separate address range for the memory and the IO. Here the only one type of address will be using because of the single bus. But here the separate. Okay, processor will use next. You can take the in this time. Processor provides separate. Processor provides processor provides separate address range. Separate address range for memory and IO. On the left side, processor provides the more address lines for the accessing the memory. Processor provides more address lines for accessing memory. On the right side, on IO mapped IO side, less address lines for the accessing IO. Less address lines for the accessing IO devices. Because we are using the both the only single address for the communicate between the memory to the processor and the IO to the processor. That's what we have the more address lines. Okay, more address lines, because in order to communicate to the processor we have the only one address line to with the both for the memory and the IO. Memory ಮತ್ತು IO devices communicate ಮಾಡಬೇಕಾದ್ರೆ only one type of address we will be using. That's what we have the more address lines. But ಇಲ್ಲಿ ಏನಿರುತ್ತೆ separate address lines use ಮಾಡ್ತೀವಿ because of the two buses are there. That's what the less address lines are present to in order to communicate with the IO devices, not IO devices. Okay, in this third one is what the more decoding is possible. More decoding is required. More decoding is required because of the on a single bus we are communicating to the both even the memory and the IO devices. On the right side, less decoding is required. Less decoding is required. Fourth one is what the memory control signals used to control the read and write operations. Memory control signals are used in the memory control signals are used required. More decoding is required. Here the less decoding is required. Less decoding is required. Here the memory control signals are used. Memory control signals are used to control the read and write operations. To control read and write operations. Read and write IO operations. Right, read and write IO operations. Okay, fourth one is here IO control signals are used to control the read and write IO operations. Here the only the memory control signals are using, okay, because of the only single bus. We will be using the same memory instruction set is used for both the memory and even the IO devices. But here the separate instruction set are used. That's what we have the IO control signals are used. Okay, in this we will be using the IO control signals for in order to communicate with the IO devices. But memory control signals are used to communicate with the read and write operations of the IO devices. But in the IO control signals, but in the IO control in the IO mapped IO, only the IO control signals are used. Only the IO control signals are used to communicate with the IO devices. IO devices. But in the memory mapped IO, the memory control signals are used to communicate with the IO devices. ಇಲ್ಲಿ ಏನು ಮಾಡ್ತೀವಿ ಮೆಮೊರಿ ಕಂಟ್ರೋಲ್ ಸಿಗ್ನಲ್ಸ್ ಯೂಸ್ ಮಾಡ್ತೀವಿ ಫಾರ್ ಇನ್ ಆರ್ಡರ್ ಟು ಕಮ್ಯುನಿಕೇಟ್ ವಿತ್ ದ ಐಒ ಡಿವೈಸಸ್ ಬಟ್ ಇನ್ ದ ಐಒ ಮ್ಯಾಪ್ಡ್ ಐಒದಾಗ ಏನು ಮಾಡ್ತೀವಿ ಐಒ ಕಂಟ್ರೋಲ್ ಸಿಗ್ನಲ್ಸ್ ಆರ್ ಯೂಸ್ಡ್ ಇನ್ ಆರ್ಡರ್ ಟು ಕಮ್ಯುನಿಕೇಟ್ ವಿತ್ ವಾಟ್ ದ ಐಒ ಡಿವೈಸಸ್ to control read and write IO operations. Read and write operations. Okay, these are there some differences between the memory mapped IO and the IO mapped IO. First one is what the memory mapped IO. Memory and the IO device share only what the entire address. Okay, under address range of the processor. Okay, it will be using the large. Okay, which will be using the big address range here. But here the processor provides only the address range for the separate. Okay, the processor provides only separate. This is what the for the memory and the IO. And the for the processor provides for the more address lines here. Processor provides here the less address lines here. Okay, the in order to access the memory, more decoding is required here, less decoding is required here. Here the memory control signals are used to in order to communicate with the IO input IO read write IO operations. So the similarly the IO control signals are used to communicate with the IO devices for the read and write operations of the IO devices. These are the some differences between the memory mapped IO and the IO mapped IO. ಆಯ್ತು ಇದು ನಾನು ಏನು ವಾಟ್ ಎವರ್ ಐ ಆಮ್ ರೈಟಿಂಗ್ ರಿಟರ್ನ್ ಆನ್ ದ ಮೈ ನೋಟ್ಸ್ ಇಸ್ ಮುಗೀತು ಅಷ್ಟೇ ಬರೆದ್ರೆ ನಡೀತದೆ. Okay, next take the heading as the IO interface. Copy this one completely. IO interface. How to interface? Interface is used to connect the IO devices. What is that interface? System bus. System bus itself consists of the what the address lines, control lines, and also even the data lines also. Data bus. That's what you are writing here. Assignment you are writing. You are not concentrating in classroom. Just to copy that one. Copy.